Good day, class. Today we'll be discussing Chapter 2, Lesson 1, Unit Rates. On page 124 of your first workbook is where we will begin. We begin with how to calculate a unit rate. And before we can learn how to calculate a unit rate, we must learn two new words. The first word we're going to discuss is a rate. And our definition given to us says a ratio that compares two quantities with different kinds of units is called a rate. For example, here they give us how many times a heart beats in 2 minutes time. Now we have two units. We have the beating of the heart and we have the time measurement of minutes. Now those two things are not directly related. The beating of a heart is a muscular action and minutes is a measurement of time. Individually, these two things have nothing in common, but you can relate the two things together. You can measure how many times your heart beats in 2 minutes in this case. So a rate is basically just some number of something, whatever you want to count, compared to another number of something else. Maybe it's the number of chocolate chip cookies to oatmeal raisin cookies. Maybe it's the number of wins to losses. Maybe it's the number of boys to girls in the class. Whatever you want, whatever two things you're measuring can be represented as a rate. And the rate is always written in this form, which looks like a fraction or a rational number. Now, our next term we have is unit rate. And it says in the book, when a unit rate is simplified so that it has a denominator of 1 unit, it is called a unit rate. So the difference between a unit rate and a rate is as follows. A rate is just two numbers, right? Something over something else. A unit rate is something compared to 1. You have to have a 1 on the bottom to make it a unit rate. If you don't have a 1, then you just have a regular old rate. So we took our first example. If we measured our heart beating 160 beats in 2 minutes, that's a rate. But when we find out how many times it beats in 1 minute, and for example, we have 80 beats in this case, then we have a unit rate. Unit rates have to have the number 1 on the bottom. Regular rates are just two numbers, whatever they may be. So that's pretty much the difference between those two. Let's go ahead and continue with our examples, and we'll move down. And it says here, the table below shows some common unit rates. Miles per hour, that's how many miles you go or move in 1 hour. Because we have a 1 on the bottom, that's a unit rate. We have number of miles per gallon. When you guys start driving, you guys are going to be thinking about all these things when you purchase your first car. And the number of miles, which is a distance, compared to how far we go with gasoline, in this case 1 gallon. Gallon is volume. This is distance, this is volume. Individually, they have nothing in common, but they can be used together to make a unit rate. Here we have number of dollars in 1 pound. Maybe you're buying some kind of produce item, vegetables, fruit, whatever, and they might sell them a certain amount of money by the pound, which is quite often the case. In that case, you're actually looking at unit rates. So when we're driving, shopping for vehicles, or even shopping for groceries, we encounter unit rates all the time. You have some abbreviations here. Most of you guys know these already. And then you have some other names that are associated with them. These are very important to know for this lesson because you're going to be using them from here on out in this year. Now that takes us to our first example. In our first example, we have Adrienne. Adrienne biked 24 miles in 4 hours. If she biked at a constant speed, how many miles did she ride in 1 hour? So let's go ahead and break this example down just a little more. So I'll go ahead and, maybe with the correct tool, I'll go ahead and kind of cover up everything that I have here. There we go. And let's just go ahead and explain what we have going on here. So in this example, we have Adrienne. We know that she went 24 miles in 4 hours. Typically, we like to put things with time and distance in this order, with distance on top and time on the bottom, which is perfectly acceptable. So here, we have 24 miles in 4 hours. This right here is a rate. That's because we just have two numbers, 24 compared to 4. But the question goes on to say, if she biked at a constant speed, how many miles did she ride in 1 hour? So let's assume that Adrienne never slowed down or sped up, and her speed was always the same. That's what constant speed means. Constant means always being the same without changing. So she's in the zone, she's riding her bike. She goes 24 miles in 1 hour. We want to know about how far did she go in 1 hour. Well, all we have to do is divide the top number, the numerator, divided by the denominator. 24 divided by 4 is 6. But you have to know what you're measuring. If I have hours down here and I have hours down here in the denominator, and I have miles up here in the numerator, then I know I also still have miles up here in this numerator. So I have 6 miles in 1 hour. This is now a unit rate. And the reason is because we have a 1 on the denominator. So miles, which measures distance, and hours, which measures time, these are two different units, but when you have one number compared to one something else, one unit of something, you have what's called a unit rate. So if you want to see, you can also find other unit rates based on the first one. If we had 24 miles in 4 hours, you could also break it down again just by simplifying the fraction, and you would see you have 12 miles in 2 hours, and if you simplify it again, you get back to the 6 miles per hour. You can say per instead of saying 1. They both mean the same exact thing. So this is how we do example 1. Your task now is to go ahead and work on the got it down here for A and B. They want you to calculate each unit rate. That means they want to know how much per 1. Round to the nearest hundredth. If you don't know what rounding to the nearest hundredth means, that means if you have to have any decimal numbers written on here, that the decimal should not go any further than the nearest hundredths place. So here's a decimal point. This would be the tenths. This would be the hundredths. None of your answers for A or B should go past 2 decimal places if you end up with a decimal answer. Now, I want to address the stop and reflect over here before we move on to the got it's. Here it says circle the unit rate below that represents 18 cans for $6. So if I buy 18 cans of some product for $6, I can then start simplifying it to get a unit rate. I can get 9 cans for $3, and I could even get, if I keep going, I can now get 3 cans for $1. And when I look over here, I see the second option here has the exact same thing that I found right here. The 3 cans for $1, although it looks kind of messy. Let me clear this up. That's $1, and that's my messed up dollar sign right there. So here, that's how you do it. You could have also directly just said, what is 18 divided by 6? Well, if I divide the top and the bottom by 6, I get 3. Whoops. I get 3. It won't let me write. 3 over 1. I had to write it over here because my board will let me write to the left, apparently. So let's look at the got it's. So you have A. If you make $300, or pay, I guess it could be, for 6 hours, then we want to know the unit rate, which is how much is spent in 1 hour. What would that be? Mark your answer over here. For B, if we move or go 220 miles on 8 gallons, then how far can we go in miles on 1 gallon? Tell me there. Here, how much money do we have in 1 hour? Because remember, unit rates have to be out of 1 unit. Something, they have to be over 1. That's the whole big idea with unit rates. Now let's go ahead and move on to the next page, page 125. On page 125, we have our second example. Here we have a box of juice boxes, and it says calculate the unit price if it costs $2 for 8 juice boxes. Now, this is probably the most practical way of using unit rate because all of us at some time have been consumers at a store, at the mall, wherever, and have had to spend our own money for things. We may not like it, but we know that we have to. And when you are spending your own money, you tend to try to get what we call a better buy or a best buy. And one of the ways we figure that out is we figure out how much are we paying for something. Because we know, like in this example for number 2 here, there's more than one company that sells juice boxes. And maybe you have a certain preference. Maybe you don't care and you just want the cheaper one. Either way, you have to know how to find the better or best buy. And here's how you do it. Here they give us in this example some information. They tell us that it costs $2 for 8 juice boxes. So I'm going to go ahead and cover up the screen and explain to you just how we're going to do that. So as always, you're going to want to write down whatever information they give you. So we know that we spend $2 for 8 boxes of juice. I'll just put boxes, but this represents juice boxes. Okay, well, let's go ahead and start simplifying. Well, I'll do it easy. I know I can divide the top and the bottom by 8, so I get $1 for 4 boxes. Now, I have a 1 here, but this is not a unit rate because a unit rate, or a unit price in this case, has to have a 1 in the denominator. So now I kind of have to do some logical thinking. Let's say I have a dollar bill right here. All right, so there's our little dude, George Washington. We'll even give him some hair that he has, that crazy old school hair they have. Here's our president, George Washington, whatever. Here's our $1 bill. We know that we can get 4 boxes of juice. So if I cut this down, I know that $1 equals 4 boxes of juice. Here's a box of juice, here's another one, here's another one, and here's another one. Because if $2 equals 8 boxes, I know that $1 will be the same amount for 4 boxes. But I need to figure out how much it costs for 1 box because I want the unit price. And unit price, or like any unit rate, has to have a denominator of 1, which means I have to divide the top number by the bottom number. Now, some of you can see very easily with this example what it's going to be. What number times 4 will give you $1? And we know it's going to be 25 cents per box. But how do we prove it mathematically? This picture does a nice job, but let's say you have some numbers that aren't as compatible. So how would you prove it? Well, it's very easy. You're going to divide. You divide your numerator by your denominator. My numerator is 1. It goes in my house. My denominator is 4. It goes outside my house. Will 4 go into 1? It won't at all. So I put a 0 there, a decimal point, and I put a 0 in here. Will 4 go into 10? 4 goes into 10 2 whole times. 4 times 2 is 8. 10 minus 8 is 2. Then I add another 0. Will 4 go into 20? Yes, 5 times. 5 times 4 is 20, and I have no remainder, so now I have my price. It would cost me 25 cents approximately per box, or 25 cents per juice box. That's what I'm paying for this deal up here. But now, if this company was the only company, then I would say, all right, that's what I have to pay because it's the only company. But as we all know, there are many, many different companies that make different kinds of juice. So you could apply the same process over and over again to figure out which one actually gives you the cheapest price per box. And that is what's called finding the unit rate. And that's what this example was about. When we go back and look at our notes, we have the same thing here. The unit price, which is the same thing as unit rate, and we'll go ahead and just emphasize that here. The unit price is 25 cents per juice box, just like we found. Now, hopefully you understand that. Obviously, if you're having any questions or need some clarification, please ask. Otherwise, let's go ahead and continue down to the next part of the page. Now, before we move too fast, remember we have a got it problem right here. They want us to calculate the unit price if a 4-pack of mixed fruit sells for $2.12. So let's write down what we know so far. I'll help get you started. We know we're going to have $2.12 for 4 packs of mixed fruit, or a 4-pack. We want to know how much would 1 pack cost. That's what the unit price wants you to know. And that's what you need to figure out for part C. Let's go ahead and look down now at example 3. Example 3 is as follows. The prices of 3 different sizes of bags of dog food are given in the table. And here they are. Which size bag has the lowest price per pound rounded to the nearest cent? So there's a couple of things we have to consider before we start doing any work. We know that we're looking for the lowest price per pound. Per pound means for 1 pound of dog food. If we're checking to see how much something costs out of 1, then what we're looking for is a unit price. Now, we want to know this unit price to the nearest cent. Money, we all know, comes in to the hundredths place. So we're going to have point something something. We can have a whole number here, and then we shouldn't have any decimals longer than 2 numbers long. Now let's go ahead and apply what we know. We know we have a 40-pound bag of dog food for $49, a 20-pound bag of dog food for $23.44, and an 8-pound bag of dog food for $9.88. Well, let's just do this. Let's look at our numbers here for 40, 20, and 8. All of these numbers are multiples of one bigger number. What's the biggest number? Actually, let me rephrase this. What number, or what's the smallest number that 40, 20, and 8 all go into? If you're not sure what I mean, what are the multiples? Like, what are your 8s? 8, 16, 24, 32, 40, 48, and so on. What are your 20s? 20, 40, 60, 80, 100. And what are your 40s? 40, 80, 160. What's the smallest number they have in common? Well, that would be 40. So we can say that 40 pounds costs $49. That's a fact. That's given to us right here. We can say that 20 pounds gives us $23.44, but we can also double it to get 40 pounds, and then we'll also double this to figure out what that price is. For the 8-pound bag, which is the smallest bag, if we bought 5 of those bags, we would have 40 pounds, which means we would spend 5 times the price. So let's go ahead and figure out which one's the better deal. I'm going to go ahead and kind of skip some steps a little bit and use my calculator over here. So we know 40 pounds is $49. That's our first one. All right, that's not too bad. 20 pounds is $23.44. So if I double 20 pounds, I'll get the price for 2 pounds. So I'll take my $23.44. I'm going to go ahead and backspace a little, multiply it times 2. And when I do that, I get $46.88. So far, buying 2 20-pound bags is cheaper than buying one 40-pound bag. But let's see the last one now. Now I have my last bag, which is 8 pounds. If I buy 5 of those bags, that's 40 pounds. So that means I would spend this price 5 times. So I'll take the $9.88 for the small bag, multiply it times 5, and I get $49.40. So to buy the same amount of dog food, if I buy the first bag, I spend $49 even. If I buy 40 pounds of the second bag here, I spend $46.88. And if I buy 5 bags of the smallest one, I spend $49.40. This ends up being the most expensive one, so I don't want that. This one's just barely more expensive than this other one. So my best bet would be this second one. Now, what if the question wasn't what has the lowest price, but what is the lowest price per pound? You still have to know that because you just want to know, you want to be able to compare very easily. So let's go ahead and divide. We know that if it's $49 for 40 pounds, then all you have to do is divide $49 divided by the amount of pounds you have, which is 40, and then we get this decimal. But remember, money does not go to 3 decimal places, so we're going to go ahead and cut off our answer here. If we remember from rounding, the 5 will affect this 2 and turn it into a 3. Therefore, it's about $1.23 per pound of the first bag. Our second bag, we pay $23.44 for 20 pounds. If I divide that by 20, the number of pounds in the bag, I end up paying 1.172. Money does not go to 3 decimal places, so we'll have to cut it off right here. This last 2 will not affect the 7, so we're paying about $1.17 per pound as we see here. And finally, for our 8-pound bag, I would take the amount that we pay for the bag, $9.88, excuse me, and divide that by the number of pounds they give me, which is 8, and I get 1.235. Money does not go to the 3rd decimal place, so I'll have to use this 5 to round. The 5 will round the 3 up to a 4, so I'm spending about $1.24 per pound. Looking at these 3 prices, we can see that the 117 is, once again, the best deal, just like we found over here. So you have 2 ways to figure out when you're comparing prices of things. You can either figure out how much you're going to spend for the same amount, like I did here with all the same pounds of dog food, or you can just simply go right into the division and figure out what is the cheapest unit rate. And that's exactly what we did here in these examples. So now it is your turn. Let me go ahead and clear this screen off, and let's move down a little bit so we can talk about what's expected on the bottom of this page. So we have the got it letter D. Tito wants to buy some peanut butter to donate to the local food pantry. Tito wants to buy as much peanut butter as possible for the best price. Which brand should he buy? So here we have 4 kinds of peanut butter. We have how much you get and how much each one costs. What you need to do is figure out how much you're going to be spending on each one for 1 ounce. And you're going to do that through division. You'll divide how much you spend by how many ounces you get. This number will go in the house. This number goes outside. Do that for all 4 and write your answers here. And then go ahead and select, whoops, I can't get my circle to complete. Then go ahead and select which brand is your favorite choice and by how much are they selling their peanut butter per unit, per 1 ounce. Write that answer here. Any discussion, any questions you have, or anything you want to just check before we discuss this in class, please come see us in the morning. If not, go ahead and go to the next page, which we'll go ahead and do now. So finally, we have the top of page 126, which is example 4. And it begins with a girl named Lexi. Lexi painted 2 faces in 8 minutes at the crafts fair. At this rate, how many faces can she paint in 40 minutes? Well, that's another good thing about proportions. If everything holds true in a proportion, then your work is pretty easy for you. Now, let's go ahead and show you how we're going to do this, and I'll go ahead and kind of blank out the screen here to make it a little easier. So, what we know is that we have Lexi, and she can paint 2 faces in 8 minutes. A little note for you guys, whenever you're comparing something to time, time is almost always on the bottom unless they tell you otherwise. So always put the other thing you're doing and the time units, minutes, hours, seconds, whatever it is on the bottom. Now let's go ahead and start simplifying this. She can do 2 faces in 1 minute. I know 2 goes into 2 and 8, so I'll divide by 2. That means she does 1 face in 4 minutes. However, I need the unit rate that tells me how many she can paint in 40 minutes. So I can go ahead and I could say, all right, well, I need to figure out how many she's going to do in 40 minutes. To go from 4 to 40, I multiply times 10. Well, whatever I do at the bottom, I do to the top, and I know 1 times 10 is 10. What am I measuring? Well, the bottom has minutes, the top has face, so this would be faces. Now, what if someone asked me, how many faces can she do in 1 minute? What if I want to figure out the unit rate? Well, all I have to do is divide. What is 2 divided by 8? I'll take 2, I'll divide it by 8. 8 does not go into 2, but 8 will go into 22 times. 20 minus 16 is 4, add a 0. 8 will go into 45 times, so I get 0.25 of a face. So basically, she does like a quarter of someone's face in a minute. So looking at these 2 lovely young ladies up here, if this is considered to be 1 face, then a quarter might be, maybe in 1 minute she can get like this eye, top of the eye makeup done on 1 eye. Then another minute to get this bottom part, then another minute to get the other side, and then another minute to get this part. And that would be the 4 minutes she needs for 1 face. And you can see how that would kind of make some sense. So that's how you do number 4. There's also another way you could see this on number 4, and that's with a bar diagram. So let me go ahead and expand the size of my eraser really quick so I can erase all this a lot faster. Okay, and now let's go ahead and talk. Let's say we have 2 faces in 8 minutes. So I'm going to say this bar represents 1 face and then another face. And we know she can do 2 faces in a total of 8 minutes. So this whole second bar represents 8 minutes. Well, if the whole thing represents 8 minutes, and she's spending equal time on the first face and the second face, that means she's spending equal time here as well. So I can say, okay, 2 faces, 8 minutes. That means 1 face is done in 4 minutes. There's a rate again that we can use. And then you can always go bigger. If you want to go multiples of 4, you can multiply to get more and more faces, given more time, or you can always work backwards. So this is just a picture way of relating faces to minutes, and you can do this with many other proportions as you'll see in our examples. So let's go ahead and clear this off now, and you can go ahead and if you want to, read the other method, but it just explains what I showed you. Now, here's the true check. If you guys are following along with your notes, then you now need to go ahead and work on these following problems in the guided practice. You need to work on number 1, 2, 3, and 4. Remember, it's not good enough to simply have the answers. You actually need to know how to explain them. If you have any questions, please raise your hand and we will help you as soon as we can. Thank you very much.